Hey guys, how's everyone doing? Well, we got some unfortunate news this past weekend that we would not be returning to classes at all. I really am very, very sad that we won't be able to get back together again this school year, actually in person together. You know, and no one was hoping for this, but sometimes life throws you curveballs that you don't really have control over, and this is one of those situations. So we're going to do the best we can, finishing out the year here in Unit 7. And there are some things we can definitely learn from this and work on, and even though it's not the most ideal of situations. So we're going to move forward, keep doing video lessons for the notes, keep using ClassKick for tests and quizzes, and you have the option of either using blank PDFs that you print off Schoology or doing the work in ClassKick for the worksheets, for the study guides, formative assessments, things like that. So, let's try and stay positive, try and stay upbeat. Life will at some point return to normal. I know it's hard in the middle of the storm to look beyond the storm and know that there is a better time coming, but guys, there is a better time coming. It just isn't coming as quickly as we would like it. So let's dig in right here to Unit 7, Target 2 through 5 introduction. Now, I will tell you, we are not going to do all of the notes Targets 2 through 5. We actually are going to skip Target 2 and Target 4. Just when we looked at the amount of time we had left and what is realistic to expect you guys to be doing any learning, we had to just cut some things down. So this introduction still applies, but it really is really the way to think about this is now Unit 7, Target 3, and Target 5 introduction. And what we're going to be talking about is we're going to be focusing specifically on zeros. All right. The big kind of important characteristic that everything was founded upon back in Target 1 was the vertex. Right. That was kind of our starting point, whether we were in general form and needed to find the vertex, whether we were in vertex form and pretty much given the vertex. That was kind of the starting point for all of the work we did in Target 1 with our quadratic functions. Now what we're going to focus on are the zeros. So let's just redefine zeros here and make sure everyone knows what we're talking about. Zeros are domain values. Right? And domain values, guys, remember, are the x coordinates in our function. Domain values, x coordinates, which when substituted into a function cause the range, which again for our purposes in these functions is going to be the y coordinate, the range to equal 0. So remember, guys, zeros are not actually necessarily the number 0, but they're numbers, x values, x numbers, which make y 0. All right. Now, there are a number of different ways that we can use to find zeros. One of them is we've already looked at a little bit, graphing, right? And this was actually going to be Target 2, and we were going to learn how to use our calculator here. So that's something that we will definitely still need to be able to do, but we'll have to spend a little more time when we get to AAT working with some of those skills and calculator work. All right. Another one, I'll just stay with the ones we're not doing here, is using a mathematical process called completing the square. All right. Now, this is a very useful mathematical process here, but we're not going to be spending time on those two. The two ways that we find zeros algebraically that we are going to spend time on is factoring. That should be familiar to us. We just did a test on that. Paired with and the zero product property. And we're going to talk more about what that property is and how that works and helps us in those notes whoa, that got crazy. That just got crazy. I don't even know what's going on here. It's not even letting me erase it here. Let's just try undo. There we go. Undo. That's always the lifesaver there. All right, Target 3, and then we are going to learn one of the most famous formulas of all time in the quadratic formula. And that will definitely involve some music too when we get to target 5. All right, so again, where we're going to be focusing our time here is in target 3 and 5. These are not unimportant by any means. Target 2 and target 4, graphing and completing the square. But when we were just looking at terms of what time we had and what we felt was the most essential, this is what we went with. All right, so let's refresh our memory of zeros graphically. Right, and one important thing that we need to remember about zeros, and when we look at a graph, is that, and let me just specify here, real zeros, which are the only zeros we know about, are the x coordinates of the x-intercepts, right? So when we're working graphically, if we were using target 2, graphing, zeros are pretty easy to find, right? We can see that we have an x-intercept, point where the graph crosses the x-axis right there and right there. So we can clearly see that this ordered pair here is -4, 0. So one of my zeros, right, is -4. Now, this one is not at 1. It's in between. And we talked about this in those days. I'm totally fine with you estimating, giving me a plausible estimation of what that x coordinate might be. I'm going to go with 0.75, 0. As long as it's a decimal between 0 and 1, we would be good. So my zeros would be -4 and 0.75. All right, and we can see that 2 would be pretty similar. We would have zeros right here at 1 and just a little short of 7. So my zeros here for this one would be +1 and maybe 6.8. Right, would be a good estimation. But sometimes we don't have 2 zeros. Sometimes we have 1 0. Notice the vertex is the x-intercept. So in this case, my zeros, I really only have 1 0, 2. Now, technically, we're going to see this algebraically, and we see that's why this happens. There actually are 2 zeros. It's the same 0 twice, but we don't need to write it twice because there's only one unique number there. Now, what happens here? Notice this parabola does not cross the x-axis at all. So when we are talking about zeros, and I should say specifically, guys, real zeros, we will eventually learn about a new number set called the imaginary numbers, but we're not going to be doing that this year. So in this case, there are no zeros. Since there's no x-intercepts, there are no real zeros that we can find in this parabola here. So let's now move on from graphs to tables. Right now, again, what we have to focus on in a table, right, is a 0 from the definition will make, oops, hold on a second, there we go, we're back, make f of x, right, because what does fx say? Y, right? Make it 0. So we're looking for x values, zeros, where f of x is the range value is 0. So as we look at this table, right, the way to find the zeros is actually by starting over here in the range. And you can see right here, we have 2 ordered pairs, which have a range value of 0, right? That makes both of these ordered pairs here, these are both, I guess I should do those arrows opposite way here, right? These are both x-intercepts because the range value is 0. So that means my zeros here would be 2 and 3. All right, pretty straightforward here. Same deal in this one. We can see we have x-intercepts. So my zeros in number 2 would be -5 and 1. Here, we only see 1 0. All right, so we do see that we have a 0 of 4. But notice what happens. As I go to the left, the numbers are getting bigger. They're going up. Right? And as I go to the right, my numbers are getting bigger. They're going up, which makes this the smallest point. If I'm at 0 and I'm going up on both sides, well, that's going to be the only x-intercept, which means that is the only 0, right? The key here is this is also the vertex. When the x-intercept is also the vertex, there's only going to be 1 0, like we saw in the graph. Vertex and x-intercept means there's only going to be 1 0. All right, what about this? Well, we can see this pattern 4 5 8 4 5 8. So that means this right here is the vertex. But notice 4 is a positive number that is above the x-axis, right? 4 is above 0. And the graph goes up. As we go to the left and the right, the graph goes up. So we're starting above the x-axis. So the vertex is above the x-axis, and the graph goes up. So when will we ever cross the x-axis? And the answer is never. So in this situation, guys, you can read this table and know that there are going to be no zeros because there's not going to be any x-intercepts. All right, so let's take a look here. And we can clearly see in this graph there's 1 0, right? That's at 5. But we don't see any others. But what we see is as I go this direction, notice the numbers go up. But as I go this way, I just went down. 0 to positive numbers is going up. 0 to negative numbers is going down. But then as I go one more value to the left here, 5, 4, 3, notice I went from 0 to negative 6, but then I went from negative 6 to positive 0.8. I went from a negative number to a positive number. Well, think back about our graphs here. If my parabola was negative, like let's just say right here, and the y-coordinate that is, and then I had a point where it was positive, what had to happen in between those 2 points? Well, we had to cross the x-axis. Now, again, we don't know exactly where we would cross the x-axis, but we know it has to be somewhere in between the x-coordinates that are associated with those range values. So because the range, the y-coordinates, went from negative to positive here between negative 0.6 and 0.8, that would mean the 0 has to fall somewhere between the x-coordinates 4 and 3. So my zeros would be 5 and some number between 4 and 3. So let's just pick 3.5. Now, again, do I know that it's exactly 3.5? I don't. That's an estimation. That's a guess. But it's a pretty good guess because we know it has to fall somewhere between those two numbers. Now, when we look here, we see no zeros. There are absolutely no zeros here. But what I do see is I have a positive range value here and a negative range value here. I'm going from negative to positive. And then it's negative, 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 and positive. So once again, I have the change from a negative to a positive range value. Guys, anytime we have a change in the range from positive to negative or negative to positive, that is telling us there's a 0 there. Somewhere in between these two ordered pairs, we have an x-intercept, which means somewhere between these two x-coordinates, we're going to have a 0. So my zeros are going to be some number between -1 and -2. Let's just, for the fun of it, go with -1.2, and somewhere between 2 and 3. Let's go with 2.9. Now, again, do I know that those are the exact numbers? I certainly do not. And I would accept, if this was a problem on a quiz, I would accept any decimals as long as they fell between 2 and 3 for one of your zeros and between -1 and -2 for your other zeros. All right. These questions down below, don't really worry about these. We kind of talked through these questions in the video. These were more for group discussion, which is pretty hard to do in a video. All right, so that's kind of our introduction notes, kind of refamiliarizing ourselves with zeros, looking at zeros graphically, looking at zeros on tables, really making sure we just dig into that definition, because what we're going to move into are non-graphical, non-table, tabular, table-ish ways of finding our zeros. What we're going to be moving into is algebraic ways where we're actually creating equations and solving equations to find our zeros. So hope this introduction was good. Hopefully it got our brains in the right frame of mind to work on our zeros, and I'll see you in the Target 3 notes.